Okay, we are moving on now to graphing radical functions. Three of the functions that we've taken a look at in your math careers so far, the first of which is linear. So we have what we call parent functions. So our parent functions of the linear graph is y equals x. And we should be able to quickly from memory, if I see y equals x, know exactly what that graph looks like. Y equals x squared, y equals absolute value of x. Y equals x is a line with a y-intercept of 0 and a slope of 1. So if you think of a y-intercept of 0, and remember I'm plotting with my finger here, this is a little difficult, and a slope of 1 means over 1, up 1, there's the parent function of a linear function. Quadratic, y equals x squared. Unit 4, we focused on parabolas and quadratic functions. This is a U shape. So the vertex is at 0, 0. And I go over 1, up 1, over 2, up 4. Oh my goodness. Over 3, up 9. Oofda. And then it's a reflection over the y-axis. And then our absolute value graph, that is the shape of a V. All right, so now let's take a look at graphing radical functions. So we're going to take a look at the square root function and the cube root function. Okay, if we were to make a table for the square root function, okay, I'm going to put 0 in the middle. What is the square root of 0? Well, it's 0. Okay, so I'm going to plot that point. Well, x values go with my domain. And if I'm taking the square root of x, can I take the square root of any number? Nope. I can only take the square root of 0 and positives. So I can't take the square root of any negatives. So my domain is going to be x values greater than or equal to 0. So I'm just going to erase this and slide it up. Okay. Well, let's think about numbers that are easy to graph. If I put 1 in there, the square root of 1 is 1. Okay, so that makes sense. Square root of 1 is 1. If I put 2 in there, the square root of 2 is a decimal. If I put 3 in there, the square root of 3 is a decimal. But if I put 4 in there, the square root of 4 is 2. So I can go over 4, up 2. What would make sense as the next logical x value to put in? 9, because the square root of 9 is 3. The square root function is the part of the inverse of your quadratic function, your parabola. It is just the positive values of your parabola. Okay, a couple lessons ago, we looked at graphing inverses when we took a look at example 6. Okay, this one had the plus or minus of the square root, and that's why I included this bottom part as well. But if I'm just graphing the positive square root, you'll notice this top part is my square root function. Let's look at the cube root function. Okay, let's think of our XY table here. Well, in my square root function, I could not take the square root of a negative. Can I take the cube root of a negative? Yeah, I can. So let's put 0, 0 in the middle here. And let's think about x values that you can take the cube root of. Well, the cube root of 1 is 1. The cube root of negative 1 is negative 1. What's the next cube root we know? Positive 8 and negative 8. The cube roots of those are 2 and negative 2. I just now noticed my graph is not going by, I thought my grid went out to 10. My last graph really wasn't plotted correctly. I did plot, I'm used to these going 10 by 10, 0, 0, 1, 1, 4, 2, but 9 is way out here. 1, 2, 3, 4, 5, 6, 7. There we go. So my 8, 1, 2, 3, 4, 5, 6, 7, 8, 2. 8 is just beyond the graph. What this looks like is that. So here my domain is all real numbers. So if I'm taking an even root, my domain is just going to be x values greater than or equal to 0. But if it's an odd root, I can take the odd root of negative numbers, so my domain will be all real numbers. Okay, do you remember the transformations of a function? That's what we're going to focus on. Okay, so we are going to take these graphs and we are going to transform them. We might move them left, right, up, down. We might vertically stretch them, make them taller. Okay, this is our formula that we followed. It's been a little while since we did this, but we did do this earlier in the year. And so let's refresh what each of these values does to our graph. Okay, the h value, okay, what is underneath our radical there is going to translate our function left and right. If it is minus h, it is going to go to the right. If it is plus h, it is going to go to the left. Our k value, that translates up and down. Plus k is going to go up. Minus k is going to go down. And last but not least, that a value out in front, okay, that is a vertical stretch. And we'll take a look at that when we get to it. All right, our directions here say, state the transformations that occur in each equation. So I'm taking my parent function, which is y equals the square root of x, and I'm transforming it. Okay, my new equation is y equals the square root of x plus 2. So what am I doing to my parent function? Well, the plus 2 is like a plus k, which means I am shifting up 2. Number 2. Now it is y equals the square root of x plus 2, where the plus 2 is underneath my radical. It is inside my function here. So now it correlates with my h value. So it's left or right, and because it is a plus 2, we are going to go left 2. Number 3, now I'm taking the square root of x and multiplying by 2. Okay, so this means I have a vertical stretch of 2. How about on number 4 when we have a negative out in front? Do you remember what that does? That is going to reflect over the x-axis. All right, these last couple have more than one transformation being done to them. On number 5, the x minus 3 means we are going to go 3 to the right. The plus 4 means we are going to go 4 up. Number 6, the x plus 3 under the radical means we are going to go left 3, the minus 4 behind it, down 4, and the negative out in front is a reflection over the x-axis. All right, so what we're going to do on the graphs on the next page is we are going to be taking this parent function right here, okay? Just like we did when we were looking at parabolas and quadratics, and we are going to transform it. We are going to translate it up, down, left, right, reflect, maybe a stretch, but we're always going to be thinking about this table of values, okay? Where is your new 0, 0? And then from there, just like we did with a parabola, we're going to do 1, 1, 4, 2, 9, 3. So let's take a look. My directions say, graph the following square root functions, then list the domain and range. So we don't want to forget to list the domain and range. Hopefully I remember after I do the first one. Okay, so I've got my square root function there. And then I've got a minus 2 behind it. Okay, so each time I'm going to focus on this XY table. Okay, I'm just rewriting this from the front page. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Okay, and these are 10 by 10 grids. That's good. So as I look at number 1, it is the square root of x minus 2. So that means I'm going to go down 2. So 0, negative 2. is my new 0, 0. Okay, so think of that as your 0, 0 value. So from there, maybe I'll make that red. That's my new 0, 0. From there, we're going to go over 1, up 1. Okay, back to my 0, 0. I'm going to go over 4, up 2. Back to my 0, 0, over 9, up 3. Now I connect it, and I just have an arrow on one end. I didn't stress that earlier, but I can't, my graph doesn't go to the left. Okay, it just continues everywhere to the right. So now I want to think about what my domain and my range are. Domain is your possible X values. Okay, how far left, how far right did your graph go? Well, I didn't shift my graph left or right compared to my parent function. And the domain of my parent function was X values greater than or equal to 0. So that's going to stay the same here. The range, now that's your set of Y values. Okay, how low does your graph go? How high does your graph go? Well, how low my graph went is -2. It does go forever high. Doesn't go very quickly, but it does go forever high. So my range would be Y values greater than or equal to -2. All right, number 2. Ooh, now we're going to have a vertical stretch with this one. So that +4 underneath the radical means we're going to go left 4. Okay. And then we're also going to have a vertical stretch of 2. So my 0, 0 is going to go left 4. Now, a vertical stretch of 2 means I'm going to double each of these. So instead of over 1, up 1, I'm going to go over 1, up 2. I'm going to go over 4, up 4. Over 9, up 6. Okay, let's list our domain and our range. Now my graph was shifted 4 to the left, so my domain is going to change. So because I went 4 to the left, my domain is now X values greater than or equal to -4. My range, how low does my graph go? Well, 0 is as low as it goes, and then it goes forever up. So my range is Y values greater than or equal to 0. Okay, I would like you to pause and do the next 2 graphs on your own. If you think you can do the last 2 graphs on your own, go for that also, but you can resume after you've graphed 3 and 4 and done the domain and range. All right, for number 3, our graph went left 3 and up 1. So my new 0, 0 was at -3, 1. Notice how that relates to our domain and range. And then I forgot to do domain and range on the last one. Right 2. So now my domain is going to be x values greater than or equal to 2. And down 4 means my range is going to be y values greater than or equal to -4. Okay. Number 5. If you did those last two already, you can just kind of fast forward a little bit and check your answers here. If you haven't and you need some direct instruction, then follow along. Number 5 is just a reflection over your x-axis. So my 0, 0 is going to stay 0, 0. But instead of going over 1, up 1, we're going to go over 1, down 1. We're going to go over 4, down 2. Over 9, down 3. Oof. My domain still x values greater than or equal to 0. But now my range, 0 is my high point, and then it goes forever down. So it's y values less than or equal to 0. All right, last one. We're going to go down 4 because of that -4. And a vertical stretch of 2. So my 0, 0 is now 0, -4. And a stretch of 2, I'm going to use that table of values again, that 2, 4, 6. So over 1, up 2. Over 2. Nope, over 4. Up 4. Over 9. Up 6. My domain, I didn't shift it left or right. Okay, so my domain stays x values greater than or equal to 0, but I did go down 4. So now my range is y values greater than or equal to -4. Okay, your task assignment is to complete pages 9 and 10. And then check those from Canvas. And then you've got pages 11 and 12, which review this entire little mini packet.